the root test. Here's another convergence test.
So here's the root test. You want to analyze a series with positive terms. You're supposed to calculate this limit. Call it big L. Big L is the limit as n goes to infinity of the nth root of the nth term. Now if big L is less than 1, then the series, the sum of the a sub n's, converges. If big L is bigger than 1, then the series diverges. And if big L is equal to 1, well, then the root test is inconclusive. You'll have to try something else.
You might think that there are some reasons to really love the root test.
Well, here's an example. Let's look at the sum, n goes from 1 to infinity, of 1 over n to the nth power. I want to know whether that converges or diverges. And I'm going to use, against my better judgment, the root test. So what am I supposed to do? Well, this is a series all of whose terms are positive, so I'll calculate big L, the limit as n approaches infinity of the nth root of the nth term. Well, this is the limit as n approaches infinity. What's the nth root of the nth power? Well, that's just n. So this is the limit of 1 over n as n approaches infinity. That is 0. And 0 is less than 1. So by the root test, the series converges.
But in that case, I could have just used a comparison test.
So here's the thing to notice. Right? 1 over n to the nth power is smaller than 1 over n squared. Maybe the only confusing case is when n is 1, in which case these are equal. But then when n is 2, it's 1 over 2 squared is less than or equal to 1 over 2 squared. When n equals 3, this is 1 over 3 cubed, which is way less than 1 over 3 squared. Well, 1 over n to the n, as I've already pointed out, is positive. And I know that the sum n goes from 1 to infinity of 1 over n squared converges. That's a p series with p equals 2. So by just the comparison test, right, I've got a series now which is term-wise less than a convergent series. So by the comparison test, the sum 1 over n to the n goes from 1 to infinity, converges as well.
And that's why I'm not so impressed with the root test.
Well, here's what happens, right? People go out in the world and they're given series problems, and sometimes those series involve something to the nth power. And people see, ooh, it's something to the nth power, I'm going to apply the root test, because then I'll get rid of the nth power. And yeah, that's true, but you could also have applied the ratio test. And the ratio test is good not just when you've got powers, but also when you've got factorials floating around.
That's not to say that the root test is just entirely useless. It's not as useful, I think, as people make it out to be. All right, the ratio test is often easier to apply, and it's more likely to cause some useful cancellation. We're going to see in the future some more instances of where the root test does come in handy, but for the time being, I think your first inclination should be to reach for the ratio test.